In this video, we'll be talking about hypothesis driven development and what makes it hard. So, as this slide says, it's easier said than done. We will talk about what are the problems with monolithic architecture. So, most of our applications are monolithic, and because of that, there are certain challenges that are faced. Also, we will see how DevOps and continuous integration and continuous deployment could be the way to overcome these problems. But again, saying it is easy, but actually implementing continuous integration and continuous delivery practically is not as easy as it sounds. So then we will talk about how containerized microservices address the problems of continuous integration and continuous delivery, and then we will talk about a CD or continuous delivery and continuous deployment pipeline for building super engaging products. This is like building product increments one microservice at a time. So with this little introduction, let's dive deep, just such as what you see in the diagram on the right hand side, where you have a user interface, then you have a middleware business layer, and then you have the data at the back end. That monolithic architecture makes it really hard for you to do hypothesis driven development, because not everyone is Facebook. Like, Facebook is a monolith, but they have several hundred releases every day, but for which they have their own tool set, which they have hundreds or thousands of developers working on those. Not everyone can have that luxury. So by and large, those who are having monolithic applications take maybe a month or maybe 2 weeks, before which they can't release more frequently. I mean, their frequency of release can at best be 2 weeks or a month. So with such low frequency of releases, you end up bundling too many features into one release. So when you see the end user behavior, you cannot isolate the effect of a feature on the end user behavior, because there are several features that have gone into a release. Also, adding or removing a feature takes a lot of work, because these are typically horizontally sliced features. So you don't have a functional feature which has its own UI, its own business layer, and its own data that can be segregated. There's a lot of dependency within each layer. So you may be able to add few columns to a schema, but to have that and then have the business layer change and also UI change in response to that is hard. So it's the basic problem with the horizontally sliced architecture. So with the size of the monolith growing, it becomes harder and harder as it gets bigger and bigger. Also, making changes when you have so many dependencies, you don't know, by making a change, are you stepping on toes? It may result in regression, and you have to do end-to-end regression testing. Even for one small change, you have to do several hours of regression testing to ensure that the change that you just made is not breaking something. So the problem that we have is solved partially by the likes of Facebook, by doing continuous delivery using DevOps. So you start with continuous integration. So you check in a small piece of code, and as you can see in step number 1 to 3, you build that code as soon as you check in using continuous integration tools like Jenkins or Circle CI or Bamboo or what have you. Then at step number 4, as you can see here, you test the code using automated regression testing. You ensure that whatever you have checked in hasn't resulted in any issues. Wonderful. Then at step number 5 and 6, you have built infrastructure as code. So you release it and deploy it with a push button deployment which is fully automated, and it becomes available to the world, whatever you have built, because it's all automatic, right? So you have the infrastructure is built and the code is pushed into the infrastructure, all by running a program or a code or a script, if you will. And finally, this becomes broadly available to the world because it's on a cloud-based distributed system, and you have many analytics tools that would be, in addition to things which are very popular such as Google Analytics, there are many other tools as well that make observability and traceability possible for you to get a lot of insight into the way the user is behaving in response to the new feature that you've just built. It's a wonderful tool or set of tools that have made it possible for us to have continuous deployments in succession. Might sound a bit utopian, because in reality, if you have dealt with large applications, making small changes to large applications often is not economical because it takes too long. So, though theoretically it is possible, practically it is hard. That's because monolithic enterprise applications have long regression testing cycles. So, even though it is automated, that automated script itself may take several hours of running. And even if it fails in the middle, then you have to start from the beginning again, or you have to write idempotent way of testing where the test will start from where it left, where it broke. Continuous delivery pipelines are hardly tested because your dev, test, and prod environments are not identical because you have a huge monolith which requires a lot of resources, and you can't have those many resources available in dev, test, and prod environment. It will become resource heavy and it will cost a lot. So you end up having a environment which is a scaled down environment, maybe a laptop for your development environment, maybe some staging environment is where you do QA or testing, and then you have the full-fledged, fully equipped production environment. So if you use a particular deployment script or instructions, that can't be the same for all three. So one of the things that happens here is that if the script for production is different, or the pipeline for the production deployment is different than the deployment pipeline in dev or in test, then you're not very sure that all three pipelines are doing the same thing. In fact, they are not. And as a result, what happens is the frequency at which you get to test the deployment pipeline is less because you're not, if it was the same pipeline that you had used for all three environments, by the time your application reached production, you would have used it many times over in development and test, but that's not what is happening here. When it reaches production, it is the first time that this new set of features and new set of artifacts are being pushed into production using a pipeline which is never tested. So that is the risk that we have, and that's what makes it harder. And of course, you don't have feature toggles, feature rollback, and things that are hard to implement. I mean, you can do it, but rolling back, moving backwards in time with a large monolithic application is easier said than done. So the solution is containerized microservices. So just shrink your application to a microservice, and that's what makes it easy for you to build, test, and deploy it in a short, quick iteration using the same pipeline, because now you're not having a very resource heavy environment. In fact, your environment is a single container, or maybe a bunch of containers that are contained in a pod on a Kubernetes deployment. So one feature can be deployed at a time and built and deployed independently because that feature has its own backend, own middleware, and an own front end. So it's like a very mini micro kind of application that can be deployed in isolation into a particular Docker container, if you will. So also, the dev, test, and production environments are identically configured because all three run inside a Docker container. Feature toggles, canary releases, Bruggen deployments are for hypothesis testing. We'll see a little bit of that later. It's easy to build these things because you have packages or libraries like Spring Cloud which have these built in. So it has become like, you just have to say that, okay, I want to do a feature toggle, and then there is a recipe that is available in literature that you can just implement. Also, integration regression testing is limited to one microservice, so it doesn't take too long. It may take a minute at the most to test the entire microservice end to end in an automated way. So it's much easier than waiting for a few hours. So it is possible for you to make this small product increment, which is one feature, as a microservice, and then deploy it in production several times. You can do such small deployments several times or several hundred times in a day. So that's the direction in which Synerzip and our developers are going. So once again, to look at the solution, these product increments go through these three stages that you can see here. So you have the first continuous integration stage, in which the code quality is tested using static analysis tools. Performance testing, unit testing, container scanning, and dependency scanning is what you do in the verification stage. Then you package what you have verified, your code, into a container registry or a Maven repository or an NPM registry. Typically, you might be deploying or packaging them in container registry such as Docker Hub. These could be Docker images being put into Docker Hub. And then it is released into production. So there you may be using sophisticated tools like GitLab pages or Canary or feature flags. And we will see the difference between continuous delivery and continuous deployment. Deployment is when it finds itself in the hands of the end user. Delivery is when it becomes available, but it's not yet being released to the open to the entire user population. So in continuous deployment, again we use deploy boards, auto deploy, push button deployment, and GitLab releases. So that is the difference between these are the three stages: the verify, package, and release stage. So we'll see a little bit more into that in this build here. So continuous delivery is depicted by black arrows and continuous deployment is depicted by red arrows. And then you start with the development. Developer checks in the code into commit stage tests, which are carried out by him on his laptop before checking the code into the repository, right? I mean, he will be running some unit tests on his own laptop. It reaches the repository, which not only consists this code, but also it consists of Docker files and config maps, right? So we marry the code and the environment, or the configuration for the environment. The way your Docker environment will look like, in which your code is running, is also put in the form of scripts or Docker files or config maps, and that is checked in along with your code, because of which you'll never have a situation where you're unsure of when something goes wrong. Is it because of the environment? Because you have you just created the environment specially for the particular release, and you already know that this release works in that environment. Once that happens, you have the next stage wherein Jenkins will get triggered, and in Jenkins you'll have a test container that will automatically be brought up, and that test container will run tests like whether the API contracts are valid, whether for a JSON you are getting the desired JSON output. Also it will conduct certain unit tests, and then this will spit out the Docker files, or rather the Docker images, and then put them in Docker Hub repository. And you will have several versions of those stored in a repository. So at a time you may have a version that is deployed in production, a version that is in test, and a version that is in development, right? So you may have the latest version 3 may be in development, version 2 may be in testing, and version 1 may be in production. How you push these into is by describing the environment and the application, what resources it needs in terms of Docker images in a Kubernetes deployment. So you have a Kubernetes deployment which is descriptive. So it is the end state that you describe in a Kubernetes deployment, and it picks up the right images and puts them in pods and spins up those pods. So that is what is automated way of deploying in a distributed application, which consists of several microservices. So this is a Kubernetes container orchestration engine, which takes the Kubernetes deployment and creates the needed environment and deploys the Docker containers in that environment, first to development environment, and then you conduct some API tests, and then if you find those tests are being passed, well and good, you will promote it to test environment. If not, you will file bugs and go back to the development stage and try to fix those bugs. If it gets promoted to test, again you will conduct user acceptance testing, manual testing, performance and security testing, and then you will see the reports. If everything is okay, it will get promoted to production. If there are bugs, again it will go back to development. Finally, in production, it will have some release tests, like some sanity tests that are carried in an automated way, and if it passes all those tests, well and good. If not, then if it fails, then it will be rolled back. If it passes, then it is exposed to the market for product market validation. Users will start using it, You'll start seeing whether they are behaving the way you had expected them to behave using various tools which give you analytics information. So Optimizely or Google Analytics are some of those. And based on that, you will validate whether your hypothesis is true or false, or needs to be tweaked, or your application feature needs to be tweaked. Whatever be the outcome, there's a lot of learning that ends up giving you the next set of features that are prioritized in your backlog, and using that your development cycle can